Sure.
All right. I'm sure that's where I'm asking. But anyway, right. So my name's Mark Allen, and thanks for coming tonight. This talk isn't so much about Perl, but it is about a language that I use all the time and I like. Reached a point of enjoying it after much struggling to not enjoying it. But since we're just getting started here, if you visit this website, and I really intend for this to be a workshop, so follow along on your own laptop, etc. If you go to this website, erlangsolutions.com, there are binary packages of Erlang that are ready for Windows, Mac OS X, and 4 different flavors of Linux. All packaged as devs, RPMs, MSIs, or DMGs. So it's a good place to go if you want to install Erlang on a system without a lot of fuss. There are other ways to do it, of course. I started a website too called introducingerlang.com. It's hosted on GitHub Pages right now. It's got about, I think it's got all the content we're going to cover tonight, but actually I've also been working on an OTP application called To-Do List that spawns a bunch of processes as to-do tasks with timers and expirations and statefulness and all of that good stuff. And I'm trying to write it in a literate Erlang style, which means that it's written as a markdown document that gets automatically parsed by Rebar, which is a build tool for Erlang.
Oh, I didn't do that, Todd. I'm sorry. Anyone else use any other functional languages aside from Rennie? Yeah, cool. Right on. Does anyone write Perl in a functional way? All right, good for you. Higher order functions for the win. So I'm going to go ahead and go through some slides, and then it's mostly going to be freeform stuff. So maybe we'll stop the hangout at that point, but. The reasons why I like Erlang, what's so great about it, and this is my opinion, so your mileage may vary, but I think 5 of the things that I really like about it are that it has a really great concurrency model. It's shared nothing, no shared state. Everything's explicit message passing. There's no shared memory. It's easy to reason about. It's easy to understand what thing is doing what to what piece of data. And there are primitives in the operating system that make building massive concurrent parallel and concurrent processing quite straightforward. So that's really cool. Erlang is also really good at slicing and dicing binary data, especially network protocols. It's especially well suited for implementing binary network protocols, as you might expect, since it was written mostly for phone switches, which is a task it still does quite well today. So it's really good at that. It has a really, really neat syntax for taking a blob of binary data and parsing it bit by bit into variables that you can manipulate later on. You get kind of gratuitous SMP scaling. There's a command line switch that you can throw at the Erlang runtime that says, I want you to start 8 schedulers so that they all get locked onto a CPU. And once you get above 8 cores, the SMP scaling doesn't work quite as well. There's a current in-flight project going on right now to improve that scaling. There's a research project where some researchers in Europe are building Erlang systems that run like on 512 cores. So I expect this to improve quite a bit over the next year or 2 years as those research projects come to fruition. There are built-in fault tolerance mechanisms, so you can avoid defensive coding. One of the sort of idioms of Erlang is let it crash. So instead of writing a lot of code, to protect yourself from errors, if you get into an error state, the idiom usually is you just let the process die. And that's cool because there are other things that watch your process and they'll restart them. And hopefully you've externalized the state of your process so you can restart wherever you left off. That's kind of nice. One of the other neat things that Erlang can do is hot swap code without downtime. So Erlang can have two simultaneous copies of a library at the same time, and the runtime system automatically switches all that stuff over for you. You don't have to do anything special. You just load it into memory, and that's it. That's all. That's really all you have to do. Now there are more elaborate things that you can do with built-in tools that are harder to manage effectively, but those are the kind of the highlights, I would say. Those are the reasons why you should learn Erlang, at least in my opinion. What are some things that suck about it? Since we're being honest, string handling is really stupid. It's really stupid. I don't know why, but for whatever reason, it's represented as a list of integers in a Latin 1 range. So if you have a list of numbers that's from 0 to 255, the Erlang shell and a bunch of other tools will sort of interpret that as a string, which is clearly not necessarily correct. All right, if you have a legitimate string of numbers, a legitimate list of numbers in that range, you know, you kind of want them to be treated as a list of numbers. Library support for Erlang is sadly not that great. You know, kind of the basics are there, like common database drivers, stuff like that. It's pretty well supported, JSON libraries. But, you know, like web clients for like the new Wingding service or, you know, fancy stuff that's like super new and things that Ruby people like, you know, there's probably not going to be that Erlang library. So that's an area that needs a little love. Erlang also has a bit of a learning curve. The syntax is a little bit weird. You know, from people that come from an imperative background. I struggle with the syntax myself. It's a lot better when you get an IDE environment, like I use Vim. There are a bunch of Vim plugins to deal with Erlang pretty effectively, and that really helps me find syntax errors before I go to the compiler. But yeah, there are a lot of sort of oddities about Erlang syntax that grate people the wrong way. For whatever reason, there was a thread on Hacker News about 2 weeks ago called "Why Isn't Erlang More Popular?" or something like that, and the top-rated comment was about how the syntax was horrible. So it's quite off-putting to some people. So for whatever reason, you know, if you're like really into code aesthetics and you're not already, you know, probably just stick with Ruby or JavaScript or something that people think is lovely. Lisp, you know, I guess. So there's that. There's some other things that suck about it. There's a lot of ceremony that's involved with certain parts of Erlang. It is kind of an obscure language, so it's got that. But on the other side of that, even though it's an obscure language, there is a pretty welcoming and friendly user community. It's sadly very small in Houston, but there are definitely lots of Erlang developers out there in the internet land who can help you on Stack Overflow and whatever, and the Freenode channel, which is also decent. You know, as IRC is not necessarily a place renowned for friendliness, but the Erlang channel is all right for the most part. So it's got that going for it. Are there any questions or anything that you wanted to ask about, like right up front, before I kind of get into the basic types that Erlang comes with? Well, more and more I see companies that want to do like startups that deal with communication somehow. So chat servers and game servers and things that require massive, you know, concurrency, basically. As you're probably all aware, that WhatsApp is probably the biggest brand name user of Erlang. I just came back from the Erlang Factory conference in San Francisco. Was last weekend, and they did a talk about how they scaled Erlang for their environment. They're pushing insane amounts of user traffic every day. You know, they're doing like 12 billion connections a day. They're doing at peak. They're doing like 3.2 gigabytes of data per hour. I mean, it's insanity. So they have really wrung every last drop of performance that you can possibly get out of Erlang out of it. It's pretty cool. Yeah.
Didn't Twitter be a part of this messaging system?
I don't think so. They are pretty big in Scala. Yeah, Erlang is not so big at Twitter. They're mostly a Java shop these days. They used to have what they called the monorail, which is like their big Rails application that was like kind of version 1, and then they slowly over time replaced that with a lot of Scala services that Scala has a library called Acco that kind of steals the Erlang actor model for concurrency, and that's mostly what they're using these days. They've replaced the monorail with mostly Scala services, and that's all sitting on top of JVM. Yeah, right.
What type of integration stuff does it support? Like Perl has XS.
Yeah.
If you have a existing code base that may not be parallel, but it's got a lot of stuff behind it. You just want to start making it able to handle parallel type stuff. What's the integration like?
It's pretty strong. So there's two integration. There's actually three integration paths. One is that you can actually write. Erlang has a pretty nice interop library for C libraries, especially. So you can actually decode and encode Erlang types within C. So you can write a glue layer basically between Erlang and some arbitrary C library. So that's one. And there's another one called a C node, which is kind of the same idea, but in this case, Erlang treats the C library as an actual entire Erlang node, and all of the traffic that gets routed between the C node and the Erlang node happens through Erlang's normal communication channel process. And then the final way that you can interrupt with Erlang is through a port, and a port is like calling out the standard out and basically scraping standard out and interpreting standard out. So you can do any of those things or none of them. There's also a Java interface, J interface, if you have Java libraries and you want to run Java. Again, in the same way, you can run as a Java node. So then Erlang will treat it as the Java node as an Erlang node, and it will communicate with it in Erlang semantics. So those are the primary ways that people interface with not Erlang. Yeah.
So, want to say I heard a podcast where they were talking about Node, and I heard that Voxer uses Node. I think the sort of problems they would want to solve is very similar to what you're describing Erlang does. Is that similar in some way?
Well, I mean, I think Node has an interesting but different concurrency model, and the biggest way that it's different is that it's shared state, so all the memory is globally allocated, and the second part is that Node typically works on callbacks. So an event happens, a callback gets registered for that event, and then there could be 0 or more things that get called back following through that whole chain, right? So that's kind of Node's concurrency model. Erlang's concurrency model is completely driven 100% through processes communicating with one another. And there are a bunch of patterns that have come up over the years. Erlang is almost as old as Perl, actually, so it's been around for a long time. Almost, like I said, almost 25 years now. So there's a middleware layer called OTP, and OTP has all these patterns that let you build process communication patterns, both between compute nodes and things that you want to store state in, and hash tables and caching layers and all sorts of other stuff that you care about. So I don't know, does that answer your question? Yeah. They're sort of on the surface somewhat similar, but not really that similar. Yeah. So one of the things that I think Erlang is especially well suited for is having a really nice isolation of concurrency, right? So you have a lot of race conditions that are not necessarily obvious when you start writing concurrent code. And one of the things that Erlang is especially good at is isolating those things behind a serialization layer that's really transparent to you as a programmer. Erlang processes have this idea of a mailbox, so a message gets delivered to the mailbox. Think of the mailbox as kind of a in-memory queue, and you pull a message off that queue, you process it, you pull another one off, you process it, you pull another one off, you process it. So that way you don't have this race condition where you have A does an operation and then B overwrites A, and then you expect the let's say that you have a counter or something, right? So A writes +1 and then B writes +3, and then you read the value of the counter and you expect it to be +1, but it's actually +4, and you're like, what's going on here, and why is this happening, and all sorts of stuff like that. Erlang really protects you from that because it lets you serialize a lot of those things behind a layer that you don't really have to think about too much, unless you absolutely need to have performance, right? And then you maybe want to eliminate that, but then you have to deal with all that yourself. So, yeah.
So that brings a question to me. You mentioned that everything, the process models effectively processes to an IPC at the end of the day. What is the performance impact on that? So I know, like Perl, when you compile it with threads,
yeah,
pretty much everything has to be re-entrant, whereas normally it's not. And so
yeah.
you have all sorts of crazy stuff where static memory gets overwritten.
Yeah.
So I imagine there's a lot of copying and structures around it.
There is a lot of copying, yes. All Erlang shared nothing, no shared memory space, no shared objects. There is actually one exception to that. I don't know if we need to get into it in this talk, but there is one exception. But in general, yes, you pass everything into a process that you need to do with it, and everything that you need to communicate to something else has to go out of it. So yes, there's a lot of copying from process A to process B and so forth. That's just kind of the rules of the game. Typically, data structures in Erlang are not super huge, right? Well, the reason I say that is because since all things in Erlang, once you bind them, are immutable, instead of passing in giant binaries, it actually passes in a pointer to the binary and a range. And then you can manipulate the range, you can inspect the rest of the binary and so forth, but you cannot change the binary in any way. You can just read it. So it's a read-only thing where you don't have to copy. Like, let's say you had a JPEG or something, and it's like a megabyte, right? That would go into a special heap space that Erlang allocates and globally, and then it would say, okay, I have this JPEG, I have this JPEG, I have this JPEG. It would not copy it 3 times, right? It would just say, here's a pointer to the data. It's read-only. You can't manipulate it.
So it makes sure the guards are in place.
Yeah, everything in Erlang's immutable, and immutability changes everything, right? It changes. You don't have this thing where you have state where somehow it changes underneath you because of whatever operation. The serialization, the immutability, all of that stuff is working in your favor as a programmer to help protect you from strange concurrency problems that come up out in the wild. Like if you look at a programming language like Go or Node or other things like that, you have to really worry about those things when you get into situations where you're dealing with concurrent actors that are manipulating common state, right? So Erlang is really good about isolating you from those things. Here's some types. These are pretty straightforward. The only one that's maybe a little confusing is the binary type. You can see it's in double arrows right there. Because Erlang is so crappy at string processing, they introduced this binary string thing. This is definitely the way to go if you're going to handle strings in Erlang. You basically turn them into binary strings, and this actually ends up being a whole collection of niceness. Now, under the hood, this is all rendered as this, right? But it actually shows up in the shell as this, right? So it's a little more human-friendly to read rather than the ASCII characters that it represents. So we have tuples, we have lists, we have atoms. Atoms are kind of a unique data type, I think. They're kind of like Perl bear words, I guess. But basically they're just tags. They don't have an intrinsic operation. They're just ways to tag data. Usually you see them at the front of tuples. Like a really common idiom in Erlang is to right is the first thing in the tuple, and then the value will be afterwards, or a list, or whatever the value is. Tuples and lists can be arbitrarily deep. You can embed lists inside of lists. You can embed lists in tuples. You can embed tuples in lists. All of that stuff. There's also conversion things between a lot of these things. You can convert integers to strings and strings to integers and all the normal sort of conversion stuff that you would expect to have. Erlang also has built-in big num support, so that's nice. You can have arbitrary precision integers just out of the box. Super handy. As they grow larger, performance decreases, so you don't necessarily want to be doing that all the time, but if you need it, it's pretty handy. Are there any questions about the types before I move on?
Is it a typo in the list example where high is quoted?
No.
Are there differences between binary strings and strings?
Yes, this one has double arrows and this one has quotes. No, I know that's a little flippant, but to Erlang, this is actually rendered as the capital letter H ASCII value, the lowercase I ASCII value, and the exclamation point ASCII value. This is actually not a binary string. It's actually a list. So if you were to look at this list in memory, it would actually be it'd be the integer 1, a list of 3. Correct. Right. If you're looking in memory, you will not actually see a string there at all. It will be a list of numbers.
Is it a sublist or is it a spliced?
It's its own separate list. So it is a list of 3 elements.
So
Yeah.
it's basically a pointer to a array of characters.
No, it's actually a list of 3 elements. There are no pointers. There's no pointers in Erlang at all. The only pointers are handled internally by Erlang itself. So as a programmer, you don't get to have any pointers.
I think what I'm saying is list is 1, another list, and then 42. So there's 3 elements, and then there's a third or second list with 3 elements.
Yes, this is a list. This is a list with 3 elements in it. Then there are the ASCII H, lowercase I, and exclamation point.
Yeah.
All right. Right. So one of the other things is in Erlang, variables start with an uppercase letter, and the compiler expects them to be uppercased. So anything that you type into the shell that with an uppercase first letter will be considered a variable and bound that way. Atoms are all lowercase, so they do not need to be single quoted. However, there are certain libraries, for example, HTTP libraries that have uppercase atoms, and in that case, they do have to be quoted because then you have to disambiguate them between variables and atoms.
Can you take a second and talk about the binary string one more time? Just with the curly or the greater than less than signs are actually doing.
Well, it's essentially shorthand for this, right? But it's actually the ASCII numbers that are represented here. The difference between a list of this list and this list is that this is held in memory as a single blob, right? It's not a list. It's an actual binary blob of data. It's opaque to Erlang. So if you say, you know, I have this JPEG, that's an opaque data type, right? If I say I have this binary string, that's an opaque data type, even though the shell is smart enough to figure out, oh, that's a string, I'm going to show you a string, right? But internally, it's represented as a binary blob with, you know, byte 1, byte 2, byte 3, byte 4 that all represent this string hello. Was that clear?
Do you run into problems like trying to support Unicode or anything that's larger than 1 byte?
Unicode in Erlang is it's full of sharp, pointy edges. The Erlang team at Ericsson, which is the company that supports Erlang, is going to release a new version of it in April, at the end of April, and they have changed the encoding type of all Erlang modules to be UTF-8. That's fine for us because we normally don't use anything except ASCII, and ASCII is always UTF-8, and so we're all fine. But all of my friends in Europe, they're all like, oh my god, this is horrible, because they all have Latin 1 encodings, and they have comments in Latin 1, and all sorts of other things, and none of those files compile now. So they're all like, oh. Yeah, so anyway.
And Ericsson is based out of Norway or something?
Sweden.
Sweden.
Yeah.
Okay.
Yeah. So I don't know. You know, it's whatever.
And isn't that just convert all the files from Latin 1 to UTF-8 and you're done?
Well, see, that was their first response, and then they had a whole bunch of people on the mailing list say, but I have 15,000 source files.
Fine. Tell them I could write a good script.
So what they've decided to do as a compromise for the next version is the compiler is going to first open the file as UTF-8, and if it gets crap input, then it's going to reopen the file as Latin 1, and then if that fails, then it's going to give up and say, I don't know how to parse this. What could possibly go wrong? It just makes me very glad that the ASCII set is always, always, always UTF-8. So.
Sounds like there's a discrepancy between what comments and what the actual strings are treated as. You should never run into a coding problem like that.
They have adopted the Python model, which is to say they put the encoding data at the top of the file. So if you have Latin 1, you're supposed to put this file is encoded as Latin. There's like a special little comment keyword, blah, 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 Latin 1. Right? If it's UTF-8, that's the default. You don't have to put it in there. But if you want to, you can if you could be explicit, etc. But anyway, it's kind of a giant mess. All right, so I talked already about like kind of Erlang's model of the universe, its model of computing. In Perl, you think about objects, or most people think about objects, but a process is the unit of statefulness. So if you are looking at a problem and you want to decompose it in an Erlang way, you're going to look for processes. And processes need to be independent actors or objects that should exist on their own, right? For example, in my to-do list application, every task is its own process because that process has state and has facilities for storing state inside of it. When I want to ask a process what your state is, that's very straightforward to do. I can just send it a message and say, report your state, and it will send me a message back that says my state is X. So that's how you need to think about the world. When you're building an application in Erlang, you really need to think about decomposing your problem space into a process-oriented space. There are no objects, so there's no, there's no verbs, there's no anything like that. All of your verbs and all that other stuff, those are all going to be composed into functions, right? And those functions either live inside your process space or they live in a module. We'll get into like what all that's all about pretty soon. We're going to start a coding exercise on the next slide, incidentally. So if you don't already have Erlang installed, then you may want to get it installed. Variables are immutable. I've already mentioned this before, but basically Erlang has lexical scope, just like Perl does. Once a variable is bound in lexical scope, it cannot be rebound. So that means if you define x to be 5 and then later on you say it's 6, Erlang's going to say, what? It's going to say, you told me this was 5 and now you're saying it's 6, so I don't think so. It'll actually tell you that's a bad match. Erlang is very much into lambda calculus. And so for that reason, it will actually say that the left-hand side does not match the right-hand side because it's across an equal sign. So if you, just like in math, if you say 5 equals 5 and then later you can't say 5 equals 6, Erlang takes the same approach. So within lexical scope in Erlang, once you bind a variable, it's bound. It can never be changed once you bind it. Once scope is fall away, then of course you could reuse the variable if you want to. What that practically means is that you may have to update a variable with different names. So for example, if you have like a JSON structure and you remove an element from it, you'd have to rebind it to a new variable, right? It comes into your function as A, and then you take out something and then you call it A0 or A1 or new A. Those are all really common idioms. The looping construct is recursion. There are no else, or there are no while loops, there's no for loops, there's no until loops. There's no looping except recursion. There are lots of list processing functions like map and filter and member and for each and stuff like that, but those are all things that process lists directly through recursion. Even though the recursion is maybe hidden to you as a programmer, it's still recursive. Erlang is tail call optimized, so that does help save complexity and computing time and things like that.
So on the immutable variables thing, does the code end up having really hideous variable naming?
Sometimes yes. Sometimes yes.
I'm guessing people do A0, A1, A2.
Yeah, I mean, typically what you want to do, at least what I try to do, is I want to decompose my functions so that they are really, 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 really dumb. They take at most 1 or 2 or 3 inputs, and they return out a single value, right? And so because of that, I want my functions to be maybe 3 or 4 lines of Erlang. I don't want to have really super long, like 40 block lines of Erlang, because that's kind of a code smell, actually. You want nice, short, decomposed functions that are easy to test. Actually, immutability encourages that because then you don't have the naming problem, right? Because the lexical scope is different. You can have names that make sense. Now, it just so happens that there are certain things in, say, web service processing or whatever, where you do have to like manipulate some data structure like a JSON, representation, and you want to take something out or add something to it. And in those cases, you basically have to, use a variable name that makes sense. But once you bind a variable, it's bound, so you can't reuse the one you already did.
It sounds like Prolog.
It's very much like Prolog. In fact, the syntax, the original sort of prototype of Erlang was written in Prolog. It's long since been moved to C, but the syntax remains. I actually, at Erlang Factory, I met one of the co-developers, sort of one of the 3 Larry Walls of Erlang, and I asked him, why didn't you, since people hate the syntax so much, like, why didn't you guys change it, 20 years ago? And he's like, well, it was a big fight, and I just didn't feel like having it, and there were other things to do that were more important, basically. He said, if if I had known at the time that this was going to be so dramatic, that maybe it would have been higher priority, but it's kind of been that way for a while. So the other thing that I wanted to point out before we get into coding is that logic branches are accomplished through pattern matching. And if you haven't used functional programming language before, pattern matching is kind of one of those things that makes you tilt your head a little bit. But the idea here is basically that you can use the way that you make Erlang take decision branches is by matching up things inside the function heads. So for example, if you have a function and the first argument of that function is a tuple, then Erlang will only dispatch input that matches what your function head says, right? So if you have a list in the first position, it will not be dispatched to that function at all. If you have a tuple and the tuple matches the arity, right, the number of arguments that's in there, then it will get dispatched, and it will get bound to the variables that are in the tuple. And I know this doesn't make any sense to you guys right now, but when you look at some code, it probably will make more sense. All right, so that's what I have so far. Are there any more questions to talk about before we get into our programming exercise for the first, 20 minutes, I guess? Hopefully it won't take longer than that, but all right, questions? Does anyone need help getting Erlang installed on their?
Many questions, but
all right, fine. So I want us to write FizzBuzz. You guys know what FizzBuzz is? Right, this is a really elementary programming exercise. It's used in some job interview scenarios, but basically the idea is we're going to generate a list of integers from 1 to 100, and for every number, if the output's divisible by 3, you need to output fizz. If it's divisible by 5, you need to output buzz, and if it's divisible by 3 and 5, you need to output fizzbuzz together. And just so you guys can have an idea of what it looks like, here's Perl in 46 characters. Just because I'm crazy like that. So it can be done in a really compact expression, but this is the basic idea. So that's what I'd like to work on. There's a couple of things that I need to tell you. First is that you can't. Maybe the first thing we should do is start the Erlang shell. So if you haven't already, go ahead and start the Erlang shell. It's called Erl. It's E-R-L, and hit enter, and it'll take you to a prompt. And the first thing that you'll see is the prompt, and you can just go ahead and play with things. Like for example, you can put in strings or binary strings. You can put in integers. You can do simple addition, subtraction, multiplication, stuff like that. There's also a function that will be helpful for this exercise called lists. It's lists with a plural. I'll just write it over here on the board, I think. It'll just be easiest that way. So it's called lists sec, and it takes 2 arguments. The first one is what number you want to start at, and the last one is what you want to end at. And what this does is it generates a list of integers from start to end. So in this case, from 1 to 100. So that's one thing that you're going to need for FizzBuzz. Another thing that you're going to need is this one. So Erlang has I/O library. It's called I/O. I know it's crazy. It has a function called format. Format is much like printf in Perl and in C. It takes a format specifier. In this case, you probably want to use ~s. ~s means string, and it takes another argument, and that is the list of things to print out here. So that might be an integer, right? So there's that. This can also just be a string too, right? Like fizz. So those are 2 functions that you maybe want to play with on the command line as well.
Can you not just do this instead of ~s?
No, you can't. I/O format always requires a format specifier. It doesn't. You can actually print a direct string, but then you have to give it an empty list. So you could put as your string, you could put fizz over here, but then this argument has to be empty because it always expects 2 arguments. and the second one has to be a list, because otherwise it won't be happy. So there's that. So let me go back to the rules just so everyone's clear on what they are. Oh, one other thing that you're going to need that you probably don't know. Erlang has a modulo function, and it's called, it's called rem, as in remainder. Okay, so that's another thing you'll probably need for this exercise. Whoops. Yeah, rem was what? Remark, I think. Also in shell scripting. Oh, I didn't cover Erlang functions, so let me do that real quick. It's kind of important. So you're going to need two things, right? You're going to need a file. Let's call it fizzbuzz.erl. Okay? And in there, you're going to need a declaration. Module, fizzbuzz. They have to match. The compiler is very particular about this. You have to finish all of your syntax statements with a period, just like in grammar school. And we also need to tell Erlang what things we want to export. That is to say, what things should be callable to external things. And here, this is a list. And whatever your list is needs to go in there. Also needs a period. Usually what I do is I have a function that I just call T, or F. I just put an F here because I had a brain fart. But anyway, what you do is you write your function name, and function names in Erlang typically start with F. Not with F, but they start with a lowercase character, and we use snake case. It's not camel case. It's all snake case, like in Perl. So you'd have like function, and then you'd start your argument list, which begins with a paren, and then you'd have arg1, right, and then you'd have arg2, and so on, and then you have an arrow. And that arrow says, I'm done declaring my function, and now I'm going to start implementing it. So you'll notice that these are all variable names, and so they get bound. Okay? Does that make sense to everyone? No? Yes? Okay. All right. My suggestion to you is that you look at implementing a function for each case in fizzbuzz, right? So you'd have a function that tells if an integer is divisible by 3. You'd have a function that tells if an integer is divisible by 5. And you'd have a function that tells if an integer is divisible by 3 and 5 together. And you guys can decide what to return from those functions, but hopefully that's fairly obvious. And then basically all you have to do then is iterate over a list. We're like, well, how do we do that? We'll get to that eventually, I promise. We will. Right. So Erlang is a little weird with its REPL. The REPL only evaluates expressions. In Erlang land, a function declaration is not an expression, which is very sad. That means that you can't just go out randomly on Stack Overflow, cut and paste stuff, and put it into the REPL and watch it work. It's not like a Lisp or anything like that. So essentially, you have to do all the module construction in a text file and then compile it. In the Erlang REPL, there is a function called C, and then a module name. So C fizzbuzz period. We'll actually compile the module and load it for you, and then whatever's exported will be available for you to call as fizzbuzz : function with arguments. Does that make sense? Yes? No? Sort of?
A bit more syntax on function.
Sure, what do you want to know?
There's supposed to be a period somewhere.
Yeah, you have to end everything with a period.
So after function and the prototype period.
No, it's
arrow,
it's function, argument list, arrow, statement 1, comma, statement 2, comma, statement 3, period. So at the end of each expression, you have to put a comma, right? And at the end of your function, you have to put a period. That's how the parser knows you're done.
So period's a semicolon effectively?
In a manner of speaking, it is, but it's also not, because each individual line has to be ended with a comma. So Erlang cares a lot about commas and periods and semicolons. Semicolons are occasionally useful in Erlang for certain situations, especially for case statements, which we'll get into in just a little while. But let's see how we do with this so far. Is anyone like really stuck or need help?
Is there a way to look up docs for functions manually?
I wish that there was a good way to do that. There is a documentation program called eDocs, but it actually extracts documentation from modules. The best resource that I have found for looking up Erlang functions is actually Google. Erlang.org is the official site, and it has all of the system libraries that you can use. And it's really ugly. I'm sorry, it's not aesthetically pleasing. The code to generate this HTML was written like in 2004, and it really shows. I'm sad to say, but yeah. So Google is probably the best way to find Erlang functions that you need to know. All right. So I'll let you work on that for a few minutes. I'm going to get another drink, and we'll see where we're at when I get back. If that's cool.